The OSIRIS-REx spacecraft was designed to retrieve a sample from an asteroid. That asteroid is called Bennu. Bennu has a diameter of about 500 meters, a mass of about 78 billion kilograms, and an orbital period of 438 days. Its surface gravitational acceleration is 0.00009807 meters per second squared, which is 1/100,000th of Earth's surface gravity. It has a rotational period of 4.3 hours. As the OSIRIS-REx spacecraft approached Bennu, it was able to take successive pictures recording its rotation. Measurements also showed that the asteroid's rotation rate is accelerating, decreasing the length of its day by about a second a century. This results from differences in the albedo of the surface of the asteroid, causing different amounts of light pressure on the asteroid. This picture shows that Asteroid Bennu is actually shooting off small bits of rock and dust, some of which enter into orbit. Some of them escape the asteroid into interplanetary space, and others fall back on the asteroid. Here are some pictures showing material that has fallen back onto the surface after being ejected in one of the plumes. This shows that Asteroid Bennu is geologically active. This was not expected because it is believed that such small asteroids should have cooled to the point of being geologically inactive long ago. One of the things it discovered was the presence of a form of iron oxide called magnetite, also known as lodestone. Magnetite forms in aqueous systems due to the intense action of water. This is consistent with the material from this asteroid having formed on or in a planetary body. This makes it consistent with the exploded planet hypothesis, as well as the possibility of the material being ejected from either the Earth or Mars. However, it is not what you would expect if the solar system had formed from a cloud of dust and gas. Its orbit, however, is most consistent with the material that makes up this asteroid being ejected from the Earth during some kind of catastrophic event. There is a problem with some of these discoveries. The solar system is supposed to be 4.5 billion years old. However, at the observed acceleration of 1 second per century, Bennu would have had a rotational period of 1.4 years 4.5 billion years ago. The cause of this is called the Yorp effect, which results from differences in albedo in different areas of the asteroid. These albedo differences cause solar radiation to have an effect on the rotation of the asteroid. The impossibly slow rotation rate means that Bennu cannot have been in its current orbit for 4.5 billion years. This is not a problem if the solar system is much younger, say 6,000 years old. The proposed solution to save the 4.5 billion years is that it migrated inward by way of a mechanism similar to solar sealing. Called the Geologically effect, results of this effect cannot actually be calculated at this time. So this makes it a perfect just-so story rescuing device to save the 4.5 billion years from actual observation. The fact that Bennu shows evidence of being geologically active is also more consistent with a young solar system than one 4.5 billion years old. Here we have another case where creation models based on a young Earth and solar system are a better fit to reality than the 4.5 billion year model. While this does not disprove a 4.5 billion year old solar system, it does show which one is a better fit to reality. If you like this video, please press the subscribe button to subscribe to this channel, and also give it a thumbs up. You can also support this channel with a donation by using the link in the description.